Hi grade 12s. I thought I would do some review of chapter 5, the polynomial functions, and you can scroll through at your own leisure. I'm going to do 4 functions where we look at the properties and the sketches, and then we'll talk about, let me look here at my examples, finding values of a function, a word problem, and then just list a few other things you might want to look at with your graphing calculator and so on. First one I'm going to look at is y equals x to the 4th plus 3x cubed plus 5x minus 9. So we know quite a few things about this. Number one, it's a quartic. It is of even degree. So my brain goes immediately to quadratics because I know those so much better. And I know that it is positive because there is an invisible leading coefficient of 1. So I know very roughly that my function is going to look like that. I know that if it's an even degree positive, that my end behavior is upwards to the right and upwards to the left. So already I have an idea of what that thing is going to look like. I know the domain is all real numbers, but with even degree, I have restraints on the range. So my y value is going to be greater than or equal to, because it's going upwards, the minimum, and y is a real number. I don't happen to know that number, but I do know that there's going to be restraints on the range. I also know the y-intercept is minus 9. Because it is a quartic, I know that I can have up to 4 x-intercepts, depending on their degree, on their power. It tells me whether it goes through or bounces, and I don't know that in this form. But I know that there can be up to 3 turning points where it changes direction. So that's all from page 85. I know that this one is not an even function, where it is perfectly balanced along the x-axis, and I am going to show you that that is the case because I am going to compare f at minus x and see if it is identical to that. I'm going to put a negative x wherever there is an x, and negative x to the 4th plus 3 negative x cubed minus 2 times negative x squared plus 5 times negative x minus 9. Notice because I have this one, that will become negative 3x cubed. And this one will become negative 5x, will be different than what I started with. So this is not going to be true. It is not an even function. It's not balanced symmetrically across the y-axis. It is also not an odd function, where it is symmetrical about the origin. For odd functions, I look to see if this is true, that putting a negative x into the function, which I have right here already, will give me the exact same thing as the original function with all of the signs changed. Well, no, this one will still be x to the 4th. When I tidy that up, the sign will change on the second one. The sign will stay the same for the third one, change on that one, and stay the same for the last. So it is not an odd function because it is not true that if you put in a negative x for every x, you will get a negative of your original function. For a graph of this one, you would want a graphing calculator. For this one, do not factor, or you will hurt yourself. All right, second one. Y equals 2x, x minus 3, x plus 4. I know if I were to expand that, and I'll do that quickly for you, but you don't have to do that. I'm doing FOIL. If you were to expand that, you would see immediately that that is a cubic. That means an odd degree function. So my brain immediately goes to the line, because that will show me quickly what my end behavior is. This cubic has a positive leading coefficient. And it has 3 x-intercepts. Because it's in factored form, I can get my 3 x-intercepts from each factor. My x-intercepts are 0, 3, and negative 4. Each one of those has odd order. I always get that word, lose it somewhere. All right, odd order to the invisible power of 1. That means the function will pass through all 3 of those x-intercepts. We know because it is a positive cubic. Again, as I said, like my line, I know a positive line, which is an odd degree function, does that if the slope is positive. My cubic would do the same, it just might have a blip in the middle. So I know my end behavior. As you go to the right, your function is going to get very large. As you go to the left, we're going to go downwards. So my end behavior can be very helpful as well. My domain for a cubic is x can be any real number. Range for a cubic, unless it's a real world problem, is also any real number, because we're going to go upwards and downwards forever. This one is not an even function, where it's balanced across the y-line. And I know that simply because it's an odd degree function. You can't have a beautiful balanced across the y-line function if it looks like that. I need to consider, though, whether it is an odd function, odd degree and odd. If it is an odd function, then it is symmetric about the origin. If it is symmetric about the origin, then if I put a negative x into my function, I will get the same function, but all of the signs will be changed. So let's see if that's the case. Okay, putting negative x into the function, I'm going to have 2 times negative x, bracket, negative x take away 3, negative x plus 4. That is not the same. Oh, let me not lie to you. Let me tidy that up a little bit. Negative 2x. That will be negative x negative 3, negative x plus 4. Let's compare that to putting a negative sign in front of the entire function and see if they are the same. Which would be negative 2x, but all of those brackets would be the same as they were before. So this is different than my original function. So it is in this one, but this bracket and this bracket, oops, are not the same as each other, nor is this one and that one. So f at minus x is not identical to that. If that is not true, it is not symmetric about the origin. Okay, let's draw it from what we know. We know the end behavior. We know the x-intercepts and that they're of odd order and the function will pass through them. So we have an x-intercept there, and at 3, and at minus 4. We know that the function will do this from my end behavior, and that my function will pass through them. So we know that it somewhat looks like that. Third one, we have a function also in factored form, which is always so lovely. We know that if we were to expand this thing, we would get a cubic again. So a cubic is an odd degree. We have a positive leading coefficient of 2. So, by the way, we know that our third differences would all be the same. They wouldn't be 6 as expected, but would be 12, just by the by. So I know that this cubic is going to do that shape because I know my end behavior of odd degree positive. So as we go to the right, our function goes upwards, and as we go to the left, my function goes downward. I know my x-intercepts. Because it's in factored form, I have an x-intercept, and that's equal to 0, which would be an x-intercept of 0. This one gives me my second x-intercept of 3. The first one is of order 2. That means the function will turn around or bounce at that x-intercept. The x-intercept of 3 is of order invisible 1, an odd order. So that will pass through, the function will pass through that x-intercept. That's very helpful for drawing. We know the domain and range. For a cubic, goes forever left and right, and the range goes forever up and down. It can have up to 2 turning points. Because it's a cubic, it's always one less. I think that exhausts our possibilities, except for even and odd. It's not going to be an even function because it's a cubic. It won't balance around the y-line. It could be an odd. Let's have a look for a second. If it is an odd, not odd degree, but odd function, that's when it's symmetric about the origin. That is where we check if we insert a negative x instead of x, whether that gives us the same as the function with a negative out the front. Let's just look at it briefly. If I put a negative x right here and a negative x right there, I will get f at minus x is y equals 2 times minus x squared times minus x take away 3. I'm going to do a little algebra on that. There we go. Y equals, I don't know why I put a y in there. Sorry about that. Equals 2 times negative x squared is the same as x squared. And I'm going to factor out a negative 1 from that bracket. It's a method to my madness, I promise. Going to bring that negative sign to the front. So negative 2x squared is x plus 3. Looks like it might be negative of the original function. And it does have a negative sign out the front, which is different, but the bracket is different. Negative of our function itself would be throw a negative sign in front, 2x squared with that the way it was. Notice those two things are not exactly the same, a little bit different. That means it is not an odd function. Let's draw it quickly. We know what the end behavior is. We know that we have an x-intercept of 0, 0 and of 3, 0. But we know that it passes through the 3 and bounces at the 0. So it goes below to 0 and changes direction. So a rough sketch would be like that. The last of the kind of graphing and getting a sense of what they look like for the review. Y equals x minus 4, x plus 3 cubed. Love it because it's in factored form. If I were to expand all of that, I would have x to the 4th. I'm not going to because I like it in the form that it's in, but it is a quartic. My brain immediately goes to quadratics, which are related because they're even degree. And I know a lot about the end behavior of quadratics just because we've done them so long. It is positive because the leading coefficient is invisible 1. Okay, so I know I'm just visualizing over to the side a quadratic that is positive. Looks like that. So a quartic could just have a little bump, but do the same things. My end behavior, therefore, as we go to the right, is going to go upwards. And as your function goes to the left, it's still going to go upwards. I have two x-intercepts. The first one comes from that bracket, and it's 4. Order invisible 1. That means it's going to pass through that x-intercept. The other x-intercept comes from this bracket. Factor would be -3. Order 3. It will also pass through that x-intercept. We know the domain and range. The domain of a quartic that goes upward is all real numbers, but the range has restrictions that your y would have to be larger than or equal to the minimum value and be a real number. These things also help us get a sense of what it looks like. We know that a quartic has up to 4 x-intercepts. We know that it has 2. And we know that it has up to 3, always one less than the degree, up to 3 turning points. Let's draw a rough sketch. If I were to expand that, I could figure out my y-intercept. It happens to be -108. But I have two x-intercepts, one at 4 and one at -3. The function passes through both of those, and it approaches the sky both from the left and to the right. And so it is going to look something like that. So there is a quartic with two x-intercepts, domain and range as written. Another skill we were working on in this unit is finding values of a function. I don't know why that subtract is sunk. There it is. 3x squared minus 6x plus 9. We want you to find the values of f at 2 and f at 2w. This is just working on our function notation. F at 2, as you've watched me do for the last 17 minutes, is to put a 2 into the function wherever you have an x and solve. Watch your order of operations. 2 squared is 4, minus 12 plus 9. 3 times 4 is 12. 12 take away 12 is 0. 0 plus 9 is 9. So f at 2 equals 9. F at 2w, just to make the point that we can do function notation, we put a 2w wherever we had an x in the function and tidy up watching our order of operations. We have 3 times. 2w squared is 4w squared. Take away 6 times 2w is 12w plus 9. 12w squared minus 12w plus 9 is as good as it gets. We have used function notation. Second one in the same vein is solving this problem. A piece of cardboard is cut to form a lidless box. Squares of length x are removed from the corners, and then it is folded as shown. So we're going to fold along this and so on. And then those little sides will fold upwards and join to form that little box. We want to form an expression for the volume. So the dimensions of the length, it used to be 18 across until you cut this little section out, and from that end as well. So the length where you fold is going to be 18 minus two little pieces, each of dimension x. So 18 minus 2x. And the width, once you have cut out those two little pieces, is going to be 16 minus 2x. So our volume is length times width times height. For this particular example, our volume in terms of x, the piece that we cut out, is length 18 minus 2x, width is 16 minus 2x, and height is x. We don't have to expand that. We are just asked, what is the volume if squares of dimension 2 by 2 are removed? That means the little length that we cut out of the corners is the length of 2. So I want to know my volume when x is 2. So you don't have to expand first. You can just insert a 2 right now into the equation. So 18, take away 2 times 2, times 16 minus 2 times 2, times 2. All right, 18 minus 4 is 14, times 16 minus 4 is 12, times 2. 14 times 12 times 2 is 336, and volume is in cubic centimeters. Other skills that we've worked on mostly to be able to graph, but that you should be able to do for a test, are expanding and factoring. Expanding is where we get rid of the brackets by doing distributive law, and FOIL, which is distributive law gone nuts. For the first one, we are multiplying three things. So expanding, I can multiply in any order. I like to get rid of my FOIL first. So I would multiply those two first. Leave the 2x for a moment. X minus 5 times x plus 7 firsts would be x squared. Outside is 7x. Inside is minus 5x minus 35. Now I'm going to do distributive law. 2x times each one of those terms. And then simplify. 2x cubed plus 14x squared minus 10x squared minus 70x. Final answer, 2x cubed plus 4x squared minus 70x. Factoring, we have three things that we look for with factoring. Common factoring always first. Otherwise, trinomial, which there are simple or more difficult ones where we use decomposition. And then special things to look for are difference of squares and factoring by grouping. For the first one, my thought process would be, is there a greatest common factor for all four terms? And there isn't, other than one. So I look down further. Is it a trinomial? No, it is not. There are not three terms. So it is either a difference of squares or factoring by grouping. Difference of squares only has two terms, so it is factoring by grouping. Those two first, I would have a greatest common factor of x squared in brackets. X squared times I need another x, and I need a 4 to get those first two terms. For the second two, I'm going to take out a common factor of 8 and multiply that by x. I'm going to need a positive. Minus 8 times 4 gives me negative 32. Bingo. Final answer. One bracket has the common term of x plus 4. The second bracket has the leftovers. And there's nothing further that I can do with that one. The second one, y equals 5x squared plus 11x plus 2. My thought process is look for a greatest common factor first. Secondly, is it a trinomial? Yes, it is. There are three terms there. If it's a simple trinomial, I would have a 1 at the front. It's not. It is a more difficult trinomial. We need to use decomposition. For decomposition, I break that middle term into two parts, such that my two parts add to 11 and multiply to 10. I get that from the outer two numbers. My two numbers are 10 and 1. The order doesn't matter. I'm going to do 10x plus 1x, but you would still get to the same answer if you had it the other way around. Factoring by grouping now, the first two have a common factor of 5x. In brackets, I have x plus 2. Looking at the second two terms, they're only common factor for those two. So I'm sure to write that one down, and in brackets I have x plus 2. Final answer, the common factor of x plus 2 and the leftovers in the bracket, fully factored. Lastly, you might want to make good friends with your calculator. There will be a question on it where you need to find the maximum and minimum, which would be the vertex if you have a quadratic, or just a high point if you have quartic. Zeros are always the x-intercepts, and your graphing calculator calls them zeros. Intersection we could have. These are the buttons that you want. The calc button, second function trace, I believe, and the table can give you a table of values so that you can find the information that you need. Be sure to try a few problems with that. I have a Chapter 5 review for you in class, or your textbook is a great resource.